That's exactly it, actually. So the model that I adopted when initially starting the project was inspired by GDAL, in fact. So yes, it is a backend that I developed with the intention of it being plugged into other software. And as you mentioned, that includes desktop GIS like QGIS, ArcGIS, as well as scripting languages like Python and R and NIM. And it's also embedded in other geospatial applications, like, for example, the Open LiDAR Toolbox has WhiteBox tools embedded in it.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is John Lindsay. John is a professor in geomatics, and he's also the creator of WhiteBox Tools. So this is a toolset of over 500 geospatial analysis tools that John has created. Many of these tools have novel functionality that you won't find in other software, and they are free to use. But before we get there, I want to say a quick thank you to our sponsor. This podcast is sponsored in part by Lightbox. So you can find Lightbox at lightboxre.com. And what do they do? Well, Lightbox is a data platform, and it's an authoritative source of North American real estate and location intelligence data. So you're probably wondering, what kind of data are they an authoritative source of? So they have parcels, building footprints, administrative boundaries, census data, schools, demographics for neighborhoods, points of interest, school ratings, traffic volume for neighborhoods. As far as the property side of things goes, they have ownership information, loan and sales transactions, contacts and mailing addresses, historical aerial photography. So you can use the Lightbox platform to do your analysis in the platform itself, or there's a set of APIs that you can use to get a hold of the data that way and perhaps build your own analysis around it, or you can bulk download these data sets as files. If you're looking for a real estate information and technology platform, check out Lightbox. I'll put a link in the show notes to make it a little bit easier for you to find. Thanks, Lightbox. Really appreciate your support. Hi, John. Welcome to the podcast. You are a professor of geomatics, and you're also the creator of something called WhiteBox Tools. And WhiteBox Tools is going to be the subject of this podcast episode. Before we get there, how did you end up as a professor of geomatics, and how did you get involved in geospatial?
Oh, well, that's a good question. I've been involved in geospatial, I guess, since my PhD. I studied obviously in geography for my undergrad and my master's, but it was my PhD where I really started to get involved with GIS and geospatial. And after that, I started working at the University of Manchester in the UK, and then eventually landed here at Guelph. I mean, geomatics is, I guess, more of a Canadian term, perhaps. It's essentially what the rest of the world might refer to as GI science or geoinformatics, perhaps.
You said earlier that you really got involved with it during your PhD. Is that because it was just starting to sort of take off then? It was that we had the tools, we had the programming languages, we could start to do more with GIS, with geospatial science then?
Oh, it's true, actually. So those were pretty early days. I mean, my PhD, not so much, but my undergrad. I remember taking GIS classes in my undergrad and it being quite a new thing. These were certainly early days. There weren't the well-established GIS programs that there are now to the same extent. Of course, there was ArcGIS, there was GrassGIS, but a lot of this stuff was quite new. By the time I started my PhD, things were starting to organize themselves in the geospatial field. This was, 2001 to 2004, 2005-ish. And, these were certainly exciting times to be in the geospatial industry. You certainly felt like you could contribute as an individual and make a big difference, for sure.
And that's exactly what you did. You started contributing through something called WhiteBox Tools, and this is the part of the conversation that I'm particularly excited about. So let's start right at the basics. What is WhiteBox Tools?
So WhiteBox Tools is we like to describe it as a geospatial analysis platform. And I know the word platform has a lot of different meanings, but essentially when we say platform, we mean it is a package for geospatial analysis that you can embed into other software to help you build other types of applications.
So as soon as someone says platform, you're right, it has a lot of different connotations. Well, what is a platform? Is it a web-based thing? Is it a desktop thing? What is a platform? I think it depends on who you are and what you've used in the past. But one thing about a platform is it doesn't sound like it just happened overnight. Could you give us a bit of an understanding of the history of Whitebox tools before we jump into what it is today?
Sure thing. So I guess the roots of Whitebox tools dates back, as I said, to my PhD when I first started to get involved in geospatial. And at that point, I started to code. It was my first experience coding, and in fact, my very first thing that I ever programmed was the Freeman 1991 flow model, like flow routing technique. It's a multi-directional flow routing technique that at the time was fairly innovative. And I was studying for my comprehensive exam, and so I was reading this paper and I thought, wow, this thing is laid out so clearly. I feel like I could almost implement it, never having coded anything before in my life. And I looked up at this milk crate. I was, a student at the time, so milk crates were a major part of my furnishings. And it had an old disk of VB6, Visual Basic 6, in it that a professor had given me. And so I took this thing and I installed it on my desktop and then started to code with it, learn how to code, and I created this algorithm. I showed that to my lab mates in my research group, and they thought it was pretty impressive and asked me to add this and that. After a while, it had developed into this thing that was a full-blown GIS, and that was what I called the Terrain Analysis System, or TAS. It was a small program, but at the time it was fairly widely used. And because I didn't really know what I was doing when I started it, it was honestly a bit of a mess internally. It wasn't organized in optimal ways to be a full-blown GIS. It just sort of evolved that way. And so by about 2005, I guess, well, sorry, about 2006, I was starting to question whether or not I should carry on this way. And TAS was a freeware package, but everyone wanted me to make it open source. But admittedly, I was a little embarrassed about the source code because of how poorly organized it was. So by about 2008, when I arrived at the University of Guelph, I decided it was time to redo this thing, to start a new project based on the roots of TAS. And that was WhiteBox GAT, WhiteBox Geospatial Analysis Tools, which again was probably my best attempt at making a full-blown desktop GIS. And I developed it from the outset to be that. And I worked on that for a number of years up until about 2017, when I started to get frustrated, in part because I developed it using the Java programming language, and the front end was developed using the Swing library that was baked into Java. At that point, Java had abandoned Swing in favor of other things, and so I knew I was going to have to rewrite it. And combined at that time, I realized that a lot of people were asking me, or giving me feedback about WhiteBox GAT, that they really liked the tool set that came with it, and they wanted to be able to use those tools, say, outside of the front end, which, because of the way that it was designed, that was not really possible. And so around, well, the end of 2017, I guess December of 2017, I decided, all right, it's time for me to start afresh, and this time focus mainly on fleshing out the tool set that WhiteBox GAT had as a separate standalone thing, and not to focus on the front end, and instead to create something that could be easily plugged into other front ends that were GIS projects that were quite successful at that point, like QGIS. And so that's where WhiteBox Tools came in. And I developed WhiteBox Tools essentially as in concept, taking the tool set of WhiteBox GAT and making them so that they're portable and can be embedded easily in other software applications. And so I think it was about 2018 that WhiteBox Tools had its first release, public release, and since then the project's been growing exponentially.
So I just want to start off by pointing out that a lot of people, when they start out programming, they start out with something called Hello World, and not writing a flow model. I mean, that sounds remarkable that was your starting point for this. So you talked about tools. You moved away from the desktop to these more sort of modular kind of tools that you were talking about. How many tools are we talking about here?
So the open core of WhiteBox Tools has, I think, around 465 tools at the moment, and the extension products that we sell for generating revenue to support the platform has, I think, at the moment about 63 tools. So all told, there's about 530 some tools. Again, I'm always working with the development version, and there is always more tools in that than there is in the public releases, but that's about what we're standing at the moment. And they're all developed using a programming language called Rust. When I decided to redevelop this tool set, I decided that I wanted to use a sort of low-level systems programming language in order to ensure that they're as fast as possible and consume as little memory as possible. And so that brought me to the Rust programming language.
So you might have already mentioned this, but I just want to clarify again if you have talked about it before. Is this open source? Can I get in and see the source code and pull it apart and work on it myself?
Yeah, so WhiteBox GAT was open source, and so too is WhiteBox Tools. And again, there's two parts to WhiteBox Tools. So there's the foundation that we call the WhiteBox Tools Open Core, and it is fully open source. You can go on GitHub and take a look at the code. And in fact, the term whitebox, the notion of it is to take the idea or concept of open source software and to make it even more so. So I talk about this distinguishing characteristic between open access software and open source software, and WhiteBox Tools is really more of the former. So the notion of open access is to remove barriers for the people who are using the software to be able to examine, to inspect, to understand the source code itself. So not all of the front ends have this for WhiteBox Tools, but for all of the open core tools, in some of the front ends, there's a little view code button that you can press, and it'll bring you to, in the whatever it is now, 5,750,000 lines of code, of Rust code. It'll bring you to the specific section that correspond to the tool that you're interested in.
So we talked about this being a platform. We talked about being modular, but before, and during a previous conversation, you described it as a backend that is intended to be plugged into many front ends. When I go to the WhiteBox website, I see that there's an integration with Python, with R, with QGIS, with ArcGIS. What am I missing here in terms of integrations here? And are we talking about something like in the same way that GDAL is a back end to a lot of different front ends?
That's exactly it, actually. So the model that I adopted when initially starting the project was inspired by GDAL, in fact. So yes, it is a back end that I developed with the intention of it being plugged into other software. And as you mentioned, that includes desktop GIS like QGIS, ArcGIS, as well as scripting languages like Python and R and NIM. And it's also embedded in other geospatial applications, like, for example, the Open LiDAR Toolbox has WhiteBox Tools embedded in it. I think GMap has it. And of course, LeafMap, its analytical engine is in fact WhiteBox Tools. So there's a number of applications out there that use WhiteBox Tools to provide the analytical power that they offer.
And I'm assuming here that these WhiteBox tools, they have standard inputs and standard outputs, meaning that I could chain it together with something that I'm already using, that I don't have to use exclusively WhiteBox tools and then go over and run the rest of a process in GDAL, for example.
Yeah, and that speaks again to the inspiration for the project in the first place. So a lot of people were providing me feedback with WhiteBox GAT that they really loved using some specific tool, like maybe the depression breaching algorithm that isn't available in other types of GIS. But they wanted to be able to integrate that into their larger workflow that involved other geospatial packages. And of course, they couldn't do that with WhiteBox GAT. So with WhiteBox Tools, I've designed it in a way where you can easily integrate it into, say, a Python script that also calls GDAL, that also calls ArcPy, perhaps, and other types of geospatial libraries.
So with some of these open source tools, there's a whole bunch of dependencies, and it can be non-trivial to figure out how I'm going to make this thing work, even though a lot of the times the documentation is amazing. For people like me, I can feel a bit lost in it sometimes. I need a certain version of Python, maybe I need a certain version of GDAL, maybe I need some other things around there. Is this also the case with WhiteBox tools?
No. So I mean, you're speaking to something that is very dear to my heart, I would say. I've had similar experiences where in using certain geospatial software, and I won't name names here, it's extremely daunting when you go to install it and you realize that you have about 40 prerequisites that need to be installed in a specific order before you can actually use that software. And that is something that has always strongly bothered me about the geospatial industry in particular. And so in developing WhiteBox Tools, the idea was always to make it so that there are zero dependencies. And that has come at a cost in terms of being a guiding design principle. There are certain compromises that need to be made as a result of that. But essentially, in truth, WhiteBox Tools is just a standalone executable that you can download for your platform on our webpage. And it runs as soon as you download it. Like you can start to use it without having to install anything else. That's because there are no dependencies. And the reason for that is because I've actually coded everything in the stack. Whitebox Tools, for example, doesn't use GDAL for input output. Instead, I've coded all of the components of it that read and write different formats of geospatial data. All of the stuff between the sort of low level and the high level tools that you're using exist in the same stack, and that's why there are no dependencies.
I mean, that is kind of amazing in itself. So a lot of, I think a lot of the development that I've definitely seen, they've taken things that are already working. So they haven't reinvented the wheel. And of course, that can be understood with some negative connotations when you think about the work that you've done. But I think you've done a great job of sort of explaining why you've done it like that. So, but these other projects, they haven't done that. They've just, GDAL's working really great. I'll have that. I'll take this other thing, it's already working, and I'll build it on top of that thing there. Is there any, I can see the pros and cons of each model, but I think, what does that mean in terms of robustness, I guess is my question. And this could be understood in different ways. Robustness in terms of maintenance, so I'm assuming that the GDAL people are doing an amazing job of doing that. I don't need to worry about it. And if GDAL updates, then I get the benefit of that as well. But I guess this is not the case with what you're building with WhiteBox tools.
Well, so again, that's a truly excellent question, but I think Whitebox's design philosophy is perhaps different than many other things, in this being one of the major differences. In terms of robustness specifically, though, I would argue that while it's true, there's a lot to be gained, and certainly I wouldn't suggest that everyone adopt the model that I have here. It's very specific to this project and to my personality as a developer, I suppose. But there's also problems with robustness that comes from adopting an approach where you have essentially cobbled together several existing libraries. And I think we've all experienced that, where you update one library and all of a sudden other pieces up the stack fall apart. And that doesn't happen with Whitebox tools, because it's sort of like Apple with the Mac. They've designed hardware that is intended to run certain software, and as a result, the fact that everything down that stack is designed to communicate with one another, the whole thing works somewhat seamlessly. And I'd say it's the same for Whitebox tools. If I relied on a library for doing certain sort of lower level parts of the stack and then update that library, there can be knock-on effects that I don't fully understand as the developer, because I don't necessarily have the understanding of how that lower level library works and how it communicates with the other pieces. And that doesn't happen with Whitebox tools, because essentially I have a full vision of everything from the top end to the bottom end. And as you said, there are definitely compromises. This is not something I would recommend everyone doing by any means. And obviously it's a bit crazy, frankly, to try to do something at this scale. But there are advantages as well as disadvantages, I suppose.
I really appreciate you taking the time to sort of talk about that a little bit, and I hope you understand none of what I said was meant as a critique. It's just I'm merely trying to highlight, this is another way of doing things, and so hopefully people will go away with the idea, okay, there are pros and cons to both ways of developing tools.
Absolutely, and no, I definitely don't take it as a critique by any means. It is a very different way at developing software compared to what most people would do by any means. And it's almost counter to sort of the modern approach to developing software. And again, I think this perhaps speaks to the fact that I've been doing this for 20 odd years. And when I initially started doing this, many of these existing projects just didn't exist, or were pretty rudimentary. GDAL, I don't even remember GDAL when I first started developing software. QGIS was a completely different thing. People often said to me, why did you develop your own desktop GIS when I was working on GAT when there is QGIS? Well, QGIS was not what it is today when I started developing. So I think in part that's where it comes from.
So I think we've probably beaten around the bush enough. We've talked about where this tool set came from. We've talked about some of the development fundamentals around it, how it was designed, and the thinking behind that design. Let's talk a little bit about what we get, like what's in the box when we downloaded this thing. So if I go to your website again, whiteboxgeo.com, it looks like you've got a really great set of manuals of documentation here, and I'm looking at something, I'm on a web page called Tools Reference, and I see things like data tools, geomorphic analysis, GIS analysis, image analysis, LiDAR analysis, precision agriculture. Can you talk us through some of these things? What do I find in LiDAR analysis, for example?
Sure. So Whitebox Tools has, people often say, well, what can I use it for? And I always respond that that's a challenging thing to answer because it's a little like saying, what can I use ArcGIS for? Or what can I use QGIS for? It obviously goes to solving spatial problems generally, but there are areas that it has particular strength in. And so, you speak about the LiDAR toolbox or the collection of tools in WhiteBox tools that are geared towards LiDAR data processing. Those are all tools that are intended to take the typical LiDAR analyst from a raw point cloud all the way to, say, an interpolated digital elevation model. So there are tools that are intended to work specifically with LiDAR data and LiDAR point clouds. So, for example, there are a number of interpolation routines, things like, tinning or triangulation and IDW, inverse distance weighted interpolation, splining, that type of thing. But unlike generic, say, IDW interpolation tools that you might find in other GIS software, these are specifically geared to LiDAR data. So, for example, you can interpolate only first returns or last returns. You can interpolate only points that have a certain class. You can use or exclude in your interpolation points that have been marked as being noisy points, either high or low lying points. So these are essentially a collection of tools that help the LiDAR specialist to take raw data and extract information products from them.
So I'm hoping people have a really good understanding of what WhiteBox Tools is now. But I think if they don't, if they've still got a few questions in their mind, perhaps you could give us some examples of use cases and examples of where people are using them, how they're using them, and hopefully this will sort of get people's imaginations going, help them understand, well, how can I use this?
Yeah, so I get a lot of feedback from users currently in terms of the wonderful ways in which they're applying it. Many of which, again, are ways that I've sort of intended them to be used, and some of which are definitely ways that I hadn't anticipated. But some of the feedback that we get certainly would be things like wetland mapping projects. It's fairly widely applied in because of some of the tools that are well designed for that. Geological resource inventorying is something that we've seen it applied in. For example, creating information products for the entirety of the Australian continent using supercomputer, modeling the distribution of solar radiation in an urban setting in order to identify potential houses in which you could install photovoltaic solar panels. I've seen that sort of application a couple of times now. Digital archaeology, as I had mentioned before, is an area that people are applying the tool set in quite widely these days. Again, Guelph is an agricultural university, and so I see it very widely applied in soils mapping applications. Recently, landslide modeling, a lot of geomorphological modeling applications for sure. It's applied in forestry applications, and that's, again, particularly because of its strength in LiDAR data processing. It's always, because of my own research area, been applied very strongly for sort of digital elevation model or DEM pre-processing, particularly in applications of spatial hydrology. And that, again, sort of speaks to my area of expertise and research. And really, it's applied more than that in all kinds of applications, perhaps that I don't even know about because perhaps people haven't reached out to me. So I would definitely encourage people out there, perhaps listening to this podcast, who have been applying it in ways that perhaps I haven't talked about today, that they think I might be interested in, reaching out and letting us know. We really love to have our these tools.
So I think I mentioned this before, but something like, so you've got a group of tools that come under the heading of precision agriculture. How do you decide what tools to build? Are you looking around and seeing, well, what's available out there already, and then looking for a gap in the market, as it were, or how do you know which tools to make? Is it people asking for certain things, or is it through your own work?
It's a combination of things, really. So I would say, one, it's based on my research. So areas of strength like, say, LiDAR or geomorphometric analysis or spatial hydrology or stream network analysis, a lot of that comes out of my research needs. So in my own research as a professor, I focus on certain areas of geomatics. And so obviously I'm going to develop tools that I need. It's kind of strange, but when you develop your own GIS, there's a certain feeling of discomfort when you have to go out to other GIS to use their abilities. So whenever that happens effectively, then I'll write a tool so that I don't have to do that. My research, when it involves sort of creating cutting edge algorithms for doing certain types of processes, WhiteBox is the platform in which I disseminate that knowledge about some innovative algorithm, for example. There's also an element of receiving feedback from users. So, for example, that precision agriculture set of tools, a lot of that comes from me working at the University of Guelph, which is an agricultural based university. It has real strengths in agricultural research. And a lot of the people that I work with are frustrated when they deal with the geospatial data that they work with most intimately, which is crop yield data. And it's very noisy. You know, we have these wonderful combines that can be used to extract spatial information about the amount of crop that is removed from various parts of the field, but it comes off very, very noisy. And so that set of tools, for example, can be used to help to use geospatial techniques in order to clean that data and make it more readily available as an information product. And then there's an element of teaching. Again, the other aspect of me being a professor is that I do research, but I also teach. And we talked about this in a previous conversation, but I very much consider myself to be a geospatial tinkerer at the sort of concept of the guy who has to take apart the toaster. If I'm teaching some concept to an undergrad GIS class or an undergrad remote sensing class, I need to know how that algorithm, how that process works at a very fundamental level. And for me, that means coding it. If I can't write a tool to do a canny edge detection process on a satellite image, then I don't know that I should be teaching that. If I can't write a tool to perform a network analysis operation, then I'm not sure that I should be teaching that to an undergrad class. And I wouldn't cast that judgment on any other professor but myself. Here, I should say that it's just my nature. I really need to understand how things work at the most fundamental, basic level to have confidence enough to be able to teach it. And so that's where I'd say most of the inspiration comes from. And some of it is honestly just requests from users who say, "I've got this problem. I'd like to figure out how to do this." And sometimes they're direct. Oftentimes they're direct. Well, they'll email me and say, "Oh, I'd like to be able to do this with your tool set, and it's not yet available. Do you have any idea if you would be able to do that?" Sometimes it's indirect, where I won't lie, I spend some time scouring GIS Stack Exchange when I'm trying to procrastinate, and oftentimes really interesting problems come up there, and I think, oh, I could have a solution for them.
How many times would you have to hear a user say, "Look, I really need to be able to do this," before you would sort of consider building that tool?
That's a really good question. So it's true, if I hear multiple users requesting the same feature, then obviously it bumps up the priority queue for me. And at the same time, if it's just a single request, but it's a really interesting spatial problem that I've not thought about before, or that I can think of a unique solution for, then even with one request, it may well result in a tool. And sometimes that happens. Sometimes someone will email me in the morning, or I wake up in the morning, check my email, and they'll be like, "I've got this problem. I can't see a solution for it. Can you think of anything?" And like by afternoon, I'll have a tool written that I can send to them, and that eventually will be published in the open core as something that everyone else can use. And so that's why sometimes when you look at the tool set, you'll see like really niche tools. Some of them, many of them are obviously perhaps generic tools that you might find in other GIS, but some of them are really specific tools. And oftentimes that's inspired by a very specific need of some user. And I am often, more often than not, surprised when, I'll write one of these very specific tools for a very specific intention, and then find out years later that, many people have been using this tool and that it's benefited many others. That's what makes it all worthwhile, I guess.
So again, I am not a developer, so this might come across as a very naive question. But what if the request was, "I'd like to run these in a different environment, like a high performance computing environment, for example, or on a cell phone, or something else"? Is that something that is possible to do with these tools today, or could it be a future for some of them?
It sure is. So there are people who have definitely used WhiteBox tools on supercomputers. I can think of at least 2 or 3 examples where that's the case. It can be used in Google Earth Engine, GE type environment. It can be used sort of in web-based environments. The only thing that I haven't seen it used in currently, and this is, I think, in part just because I've not compiled it for this, is like a mobile environment. So there's no reason why technically it couldn't be used in a mobile environment. Again, the Rust programming language can certainly be compiled for, say, Android. But no doubt I could get it on iOS. It's just I've not compiled it for such, and no one in the community has done so. I don't know if it's because the guts or the intention of Whitebox is obviously more on the analytical side than the visualization side. And I might be misspeaking here, but I think mobile GIS is still much more focused on front end data visualization for people in the field than it is, raw data analysis, which typically you would still go to. I wouldn't say a more powerful computing platform, but certainly one that is maybe more conducive to interacting with, analysis.
Yeah, I think that's a really fair statement. But you mentioned the word intention, and it made me think that when I look through this list of tools that you've developed, they're so focused, so unique, and there seems to be a very clear intention behind, like that this is for exactly that thing there. I'm wondering if you can have situations where you see people using your tool for something that it wasn't intended for. And how do you feel about that? How do you react to that? Or does it matter?
I do. Well, so it doesn't matter. I want people to use it for whatever they want to use it for. I've created a set of tools here and, unleashed them on the world with the hope that people will apply them in ways that I didn't ever think that they would be applied. And I get a lot of inspiration and motivation when people do contact me and say, "Oh, I was using this tool for this application it was something I never envisioned." And a good example of that is in recent years or recent months, it's been fairly widely applied for geoarchaeology, for digital archaeology applications. And people have reached out to me to say, "Oh, we're using it for this and this type of archaeological based application." And I won't lie, in developing these tools, it's not something I was really envisioning. So seeing people applying them in ways and in domains that I had never anticipated is truly motivating. The capacity for users to take what you've created and to apply them in ways that I myself could never have envisioned is remarkable.
So earlier on, we talked about how this is a back-end design for many front ends. How did you decide which front ends to support? I'm assuming there's a certain amount of support that goes into each, or maintenance involved with each front end as ArcGIS changes, perhaps as QGIS changes, as Python changes. There must be some level of maintenance that is required there. So how do you decide which front ends to support?
I think if you speak to any open source developer of a large project, you'll hear about the balance that has to exist in order to not burn out. And, obviously developing 530 plus tools in the span of 3 or 4 years, it's been a marathon run at a sprint's pace for me. And, you can only spread yourself thin so much. And so my focus has really almost entirely been at the back end side of things. So many of the front ends that we've talked about are actually maintained by other people in the user community. In particular, Quisheng Wu, a professor in Tennessee in the United States, he has taken strides in pushing, I think, the ArcGIS front end, some of the Python, although Whitebox comes with its own Python API already, but there's a pip install that he maintains. And I think he started the R front end, which is now being maintained by another fellow, Andrew. And the QGIS front end was initially maintained and still is maintained by Alex Brewery in the Ukraine, as a result of some of the unfortunate things obviously going on in the Ukraine at the moment. Not to get too political, he's had to step back from that, and so WhiteBox Geospatial, the company, has sort of taken over, at least for now, the maintenance of that particular front end. But otherwise, I try not to guide where people create the front ends that users can interact with the project, and focus instead much more on the back end. I kind of prefer, to tell you the truth, being the anonymous guy in the background working on things without people perhaps knowing that he's there. This podcast is quite unnatural for me. It's probably one of the first public-facing things that I've done.
Well, I have to say, I think you're doing an amazing job at being a guest and slowly but surely sort of walking us through this. I really appreciate it. So we're talking about these tools. We talked about some of your thinking around the development of them. I want to go back to something you said earlier on. You talked about the development being driven by your own work, by the research that you're doing and your need and desire to teach these skills to the students that you're working with. And I remember from a previous conversation, you were talking about this idea of turning science into practice. So taking the science that you're doing and making something tangible out of it, a tool that could be applied in the real world. And I wonder if you see that this sort of move towards reproducible research as a move towards turning science into practice and help sort of getting the science out the door, getting it in the hands of people that might do amazing things with it.
Yeah, so again, you're speaking to something that is very near and dear to my heart. As a scientist, I frequently see, and again, I don't want to criticize any individuals, but I frequently see geospatial scientists, academics who, are working at the cutting edge of the field, developing innovative solutions to geospatial problems that practitioners experience on a day-to-day basis. And oftentimes, the result of that research is the publication of a journal article, which other academics can access, but frequently practitioners don't necessarily have access to. And even if they did, they don't necessarily have access to the software artifacts that implement the ideas contained in those published papers. Oftentimes academics will publish a little GitHub repo containing that implementation, but it's very specific to the application that the journal article was based on, and isn't as easily transcribed into practice. So for me, Whitebox Tools isn't just a side project. For me, it's very intimately tied to my research as the means by which I can communicate not to other academics the solutions to innovative solutions to problems that I'm working with at the sort of cutting edge of my particular field of research, but also to then communicate those ideas in the form of a usable implementation to practitioners. And that allows me a certain advantage in truth in terms of my field, because immediately, if I develop, say, a new depression breaching algorithm to better pre-process digital elevation models, well, within days, I can ensure that it's in the hands of practitioners such that they can adopt this cutting edge scientific advancement effectively. And so I've always viewed Whitebox Tools as effectively a form of disseminating the research that I'm doing, and that the students that I work with, grad students in my research group, it's the vehicle by which they can also get the work that they're doing in the hands of practitioners. And sometimes that honestly freaks them out. My grad students often are working on, as all academics are, on these very niche problems. And as you spend 2 years focused on this one little problem, you think, oh, does anyone in the world care about this problem? That's one of the side effects of doing a grad degree, I'm afraid. And there's always a point in each of their degree programs where when we get when we get to the point where we publish the tool that they're working on in the Whitebox geospatial tool set, and they'll get an email out of the blue, or I'll get an email out of the blue from some user somewhere around the world who will say, oh, I just started using this tool. It's wonderful. Can you give me some advice about, say, parameterizing it? And it always just takes them by surprise, knowing that something that they thought was so niche and they were so focused on is now being used by people, potentially thousands and thousands of people in hundreds of different countries, or 100 plus countries.
I could imagine that you would feel like you were on the hook in a different way. So you're not just publishing a journal article about this, like you're providing a tool, a service, and your name is attached to that tool or service. I could imagine that responsibility would weigh quite heavily on some of these younger students.
It does.
We've talked about this Whitebox Tools as being a platform. Right at the start, we said platform, and platform could be a lot of different things. Is there a world where this is a distribution platform of tools it is already, but is there a world where other professors come to you and say, look, I've made this thing, can you add it to your tool set, and can we distribute the knowledge as a practical thing in the platform that you've already built?
Yeah, I mean, when I talked about the notion of, the term white box indicating open access as opposed to open source software, again, one of the ideas or the inspirations there, or the hopes, I suppose, of that, was that by removing the barriers to understanding how certain tools work, it allows for iterating on those tools. It makes it much easier for people to say, oh, okay, this is how, say, the slope tool works. I could modify that to improve it to do this or that, and then to very easily, take user community contributions and to build on it in that way. It was quite idealistic and optimistic in that sense. And to some extent, that worked well with Whitebox GAT when it was written in Java. With Whitebox tools, again, certain compromises needed to be made, and I chose the Rust programming language because of its performance characteristics and the fact that it's a modern language. But it is admittedly one of the toughest languages to learn as a beginner. So if you haven't learned Rust previously, that journey of learning it is probably harder than it would be certainly for, say, Python or for Java, more common languages like that. And so up until now, effectively those 530 some tools have been contributions by myself largely, and a few of them have been by my graduate students as well. But I haven't as of yet received very many contributions from the community. But again, with the concept of Whitebox, that it's very much designed with this sort of goal in mind. Yeah.
Have you heard of people doing what you're talking about? So opening a tool up, seeing what's under the hood, how it works, and porting that to another language?
Yeah, so I think I had mentioned to you that Whitebox GAT was initially, so it was developed in Java, but in reality it was initially developed in the .NET platform, using a combination of both Visual Basic .NET and C Sharp. And the nice thing about the .NET platform was that when you press that View Code button and you saw the code that I wrote, if you didn't understand, say, C Sharp, then you could convert it to, say, Python. Like, just press a button and it would convert it. So there was a ready ability to be able to translate the toolset from one to another. And in fact, when I left the Whitebox GAT project, there was another hydrological project, that GIS project, that took that tool set and translated them into, I forget what language they translated it into, but that was something that happened then. Certainly, there's definitely the ability to do that. I think it's a little trickier to do than you might think, though, again, because those tools have been written in Rust, but they also use all of the stack that lies below the analytical part of the tool in terms of reading and writing data and everything else that goes in between. So you'd need to port all of that over as well. It's no easy undertaking. At this point, Whitebox GAT, it's been a while since I've done sort of the lines count, but it's coming in, I imagine, on close to 1 million lines of code. It's probably about somewhere between 500 and 750,000 lines of code. So it's a sizable project to port.
Yeah, it sounds like it. It sounds like an incredible undertaking. So what would you, if you had to start this again today, what would you do differently in terms of your approach to building and maintaining this?
Well, so this is my third kick at the can, admittedly. I made mistakes with TAS. I made mistakes with Whitebox GAT. On this one, I'm not going to say it's perfect by any means, but it is definitely the closest that I've come to creating exactly what was in my mind from the inception of the project. So I don't know, things that I would change about it. I would say that there are compromises that I have made for the design philosophy of Whitebox tools, and those compromises, of course, as everything does, come with certain side effects. And the side effects are ones that I'm okay with, but there are maybe consequences for other applications, other users. And so, I could certainly see designing it in a different way in order to capture different audiences, for sure. And to some extent, we're addressing some of those issues now in terms of the company and our recent development efforts. Some exciting things coming down the pipeline, for sure.
I think that's a really hard thing to know. It's like, who is this for? I think it's obviously a really important question, but an equally important question is, who is it not for? Because I think if you're for everyone, effectively you're for no one. It doesn't differentiate itself in the market. You're aiming at that big sort of the middle of the bell curve. And I think you can very quickly end up making average stuff for average people, and no one cares about average stuff. They care about specific things for their problems.
I mean, this is the problem that I have when people ask me, what is Whitebox for? And I reply and say, well, what is ArcGIS for? What is QGIS for? Because it is so broad in its scope. And I do definitely encounter this problem. Again, as a researcher, I'll frequently see people say write a paper describing some software for a very niche problem that they've been working on, and it's very easily publishable. You can very easily say, here's the tagline, this is innovation in this particular field. But Whitebox tools paint such a broad stroke, covering such large ground, that admittedly, like, I know I need to write the Whitebox tools journal article so people have things to cite, but it's a hard one to publish because in order to do so, I have to sort of break it down to here are the niche areas that it has strength in. But the reality is, in doing that, you're always sort of leaving out some of the more perhaps generic functionality that it has, because it is intended to be so broad in application. And from the user community perspective, that means that it's hard to describe the value proposition in sort of a pithy single line thing. It can be used for everything. That's probably an overstatement. Obviously, there are things that it's not particularly strong in, and things that it's much stronger in. But it does, compared to most projects, have a much broader sort of application area. And so that value proposition is certainly there, and it's there in I think maybe some of the unique tools that it offers that you won't find in other GIS. So while it has a set of tools that definitely overlap with things that you would find in QGIS and in ArcGIS, it also has a large number of tools that are very niche, that I think aren't niche in their application, broad application, but are niche in their solution, that offer certain advantages that you won't find in other things. But that's hard to say to people in sort of a pithy one-line way.
Yeah, it's not easy, but I love that sentence there. Not niche in terms of their application, but niche in terms of their solution. I thought that was brilliant. That was a great one-liner.
Maybe I need to write that one. We should put that one on the webpage.
Yeah, I think you should. Hey, so this has been fantastic. I've learned a bunch. I really appreciate you sort of walking us through this. What should people do? They've heard us talk about WhiteBox tools for a while now. Where can they go if they want to learn about this thing? Is there any particular website we can send them to, or a place on the website where it's just a great starting point? I'm guessing there's people sitting out there thinking, well, I love tools. I like working with geospatial data. What should they do to discover if WhiteBox tools is for them?
That's a good question. So, of course, the home on the web for us is www.whiteboxgeo.com. And that's our homepage now since about a year ago. And you will find all the information that you could ever want to know about the WhiteBox Tools project, in terms of the larger WhiteBox platform, in terms of the open core that we've been talking about today, as well as the extension products that extend the functionality of that. And of course, you'll find plenty of resource information in terms of the user manual that we have put. We have put so much work into that user manual to give users a source for answering the questions that they have about how to work with some of these niche tools and parameterize them, and the inputs and outputs, and what they do and how they can be used and applied. And we have a series of YouTube videos. So my business partner, Anthony, he's a reluctant YouTube star, I would say, but he's been releasing at a pretty steady pace YouTube tutorials that describe perhaps individual tools or collections of tools and how they can be used. And of course, you can find us on Twitter and LinkedIn and other social media.
Well, I'll put links to all of those places in the show notes of this episode. So I hope that helps people discover you. And I just want to say thanks. Thank you very much for building this and making it available for people, and for helping sort of spread the word about geospatial and helping people, solve niche problems. On behalf of the community, really appreciate it. Thank you.
Thank you, Daniel. It really was an honor and a privilege for me to speak to you today on your podcast. Long-term fan, and what you're doing is remarkable for the geospatial community, and the opportunity for us to perhaps get people in the user community who are less familiar or unfamiliar with WhiteBox tools out there knowing more about it is certainly an opportunity that made me come out of my sort of back-end shell, my natural reclusive nature, and to join you today. I really appreciate that opportunity.
Well, I'm really pleased you did, and it's been great talking with you. Thank you very much.
Thanks.
Thanks again to Lightbox for sponsoring this podcast episode. If you are in the US or Canada and want to locate your customers and prospects using addresses, geocoding, and property information, or if you're working in real estate, government, telecommunications, insurance, energy, or utilities, check out Lightbox. That's lightboxre.com, and there'll be a link in the show notes of this episode to make it easier for you to find. Thanks, Lightbox. Really appreciate your support. So I really hope you enjoyed that episode with John Lindsay talking about WhiteBox tools. Now, I realize when you publish an episode about WhiteBox tools and you have a sponsor, that is called Lightbox. It could be a little bit confusing, but just to clarify, Lightbox is the sponsor of this podcast episode, and the tools that John Lindsay was talking about can be found at whiteboxgeo.com. I'll put links to the sponsor and to the Whitebox tools website in the show notes of this episode to make it really easy for you to find. So that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. I really appreciate it. As always, you're more than welcome to reach out to me. Perhaps the best way of getting a hold of me is to visit mapscaping.com. You'll find a bunch of other podcasts there, some pretty amazing blog posts, and some contact information. And I would love to hear from you. Okay, that's it from me. I'll talk again next week. Bye.